Welcome again. In the previous lecture, we have discussed about different types of manual material handling tasks with the concept of ergonomics for the saving of the spine to avoid as much as possible the lower back pain. That is the one of the main reason for disability in the world, in occupational world, we can say that. So, in the same direction, NIOSH has given an equation which can help us to find out the recommended weight limit, but that is for a specific kind of lifting task. There are certain steps in which this equation was evolved. Initially, to reduce the occurrence of lifting related to lower back pain. Then it was designed an equation which can give a weight value which can be allowed in particular type of task where it is supposed that there is an origin from which load is supposed to be lifted, and there would be a destination where the load had to be placed. So for that case, there are certain conditions in which NIOSH lifting equation can be applied. But this equation had been modified in 1991, then in 1981, and then 1991. 1981, it was only limited to the sagittal plane, means our body is supposed to be in three planes: lateral, sagittal, and coronal. So in sagittal plane means you are lifting by flexion and extension of the trunk. But later on, it was modified with the concept of having some kind of asymmetry either on the either direction with a kind of type of coupling in the load. So this equation was modified, and equation is this NIOSH lifting equation, which helps us to find out the appropriate weight limit, is based on all three possible criteria for the analysis of manual material handling: biomechanical analysis, physiological analysis, as well as psychophysical analysis. Biomechanically, they have found out that 3.4 kilonewton force is a cutoff value for the body, maximum compression of the disc. So the torque which are coming on the disc should not be making the load of that much limit. Second is the energy consumption, energy expenditure of the body. Either we calculate in terms of oxygen intake, or we calculate in terms of heart rate, or the other ways we can find out the energy expenditure. It should not go beyond 19.7 kilojoules per minute. And the acceptability. Acceptability should be for maximum population involved in that particular task. So based on the acceptability, we get the assurance of that particular technique, whether it is going to be accepted, whether it is going to reduce the risk of injuries or not. There are some conditions where we cannot apply NIOSH lifting equation. We can apply NIOSH lifting equation as we see this picture, that when you are lifting the job with two hands from one origin to destination. So that is the situation in which NIOSH lifting equation is applied. But these are certain conditions where we cannot apply lifting equation. If these conditions exist, we will not apply lifting equation. We will go for other kind of psychophysical methods by which we can evaluate the acceptability of the load. First is when lifting or lowering is by one hand, lifting or lowering over 8 hours of duration, lifting or lowering while seated or kneeling, lifting or lowering in a restricted work space, for example, there is no sufficient empty space around there, lifting or lowering while carrying, pushing or pulling. If these three or more than one task are combined, then we will not apply this equation. If lifting or lowering with wheelbarrows or shovels, then also the situation is different. We know the F.W. Taylor's or Gilbert's experiments for shovel work. Lifting and lowering with high speed, for example 30 inches per second. If we have a very fast pace of work, then also we will not apply this lifting equation. It is for the moderate speed of working. Lifting or lowering with unreasonable foot or floor coupling, lifting or lowering in unfavorable environment, when temperature is high or humidity is high, then we are not going to consider only NIOSH lifting equation. Even if we have applied, then we have to go for other kind of modifications. This is what is called as NIOSH lifting equation. This equation is based on 6 factors and 1 load constant. It is supposed that 23 kgs of load is being lifted. Then according to that, there are 6 multipliers, and this equation is nothing but the multiplication of these 7 items. 1 is constant and the 6 are variables. These variables are depending upon the origin, destination, body posture, body asymmetry. So whether the body is twisted or not, we have to see. This is with respect to the center line in the sagittal plane, or how much angle the load is making with the sagittal plane. That is twisting. So that is asymmetry. One is horizontal multiplier, depending upon the distance of the weight with respect to the body line. This is vertical multiplier, distance of the weight with respect to the floor. This is the distance moved to be moved. This is asymmetry, the angular deviation in the trunk. This is the frequency of lift. This is a type of coupling. So these 6 multipliers, the multipliers word is used because they are with reference to the actual values of these variables. So variables are converted into some multipliers, and those multipliers are, when multiplied with the load constant, we give a reference value that is called as recommended weight limits. So recommended weight limits is, we can go for load divided by the recommended weight limits. It is called as lifting index. So if lifting index is more than 1, we are at a risk. If lifting index is less than 1, we are not at a risk. So that lifting index we can calculate and see the level of the risk involved in here. And if risk involved is more, we have to reduce one of the variable. Either it is the height of the destination, height of the origin, or the distance to be moved, type of coupling, asymmetry, etc. This is horizontal distance from the center line to the center line of the load. So this is h. With respect to the value of h in centimeters, we can pick up the multiplier value. I'll show you how to calculate the multiplier with respect to the actual value of the variable. Second is, this is the distance from the center of the load to the floor, which is our vertical distance. Distance moved is d. We are moving in the vertical direction. Whatever distance we have moved, that is called as distance moved. It's not called in a horizontal direction because we are considering this h value for origin as well as for destination. So for origin, we will calculate the recommended weight limit separately. For destination, we will calculate the recommended weight limit separately. So in both the cases, horizontal distance will be different value. Now this is asymmetry. This is our sagittal plane of the body, which is parallel. It divides the body exactly into 2 halves. We call it sagittal plane. So that way, this angular deviation with respect to sagittal plane is called our asymmetry here. Asymmetry, that is measured in degrees. So these are variables which we measure from taking the picture of the task or measuring on the workplace. We can see is further over here, which is already seen, that what are the distances here. In this picture, it is very clear what is the meaning of asymmetry. So this is load. The center of the load falls here, which is at an angle with respect to sagittal plane. This is an angle with respect to cylindrical plane. This is our asymmetry. So that is measured in degrees. So when we have measured these variables, we can go for what is called as picking up the values of the respective multipliers. There are certain things which are important. One is lifting duration, whether it is a job for less than 8 hours or not. Coupling is proper, good cuts or good gripping or handles are there, significant control on the floor. So these things we have to ensure before applying NIOSH Lifting Equation. See again, these are the multipliers which are basically the converted values from the actual measurement to certain numbers. Here we see that how to calculate the values of multipliers with respect to the actual variables, actual values measured on the diagram. So on the diagram we have measured horizontal distance, vertical distance, distance moved. We have measured asymmetry in angle, and we know the frequency and the type of coupling. So depending upon the distance which we have measured in centimeters, so we are talking about metric system, so in centimeters we can put the value here. We will divide 25 by that particular value and we can get a multiplier over here. For vertical value, whatever we have, either 70 centimeter, 20 centimeter, 30 centimeter, whatever it is, we will put it in this formula and we can get the vertical multiplier. For distance, difference between the height of origin and destination, we can put this value in centimeters here, we can have the distance multiplier. For asymmetry, the angular deviation at origin as well as at the destination. Both places we have to calculate the recommended weight limits. Then whichever is less, we have to go for that. Or if the lifting index is going to be higher in the cases, either it at destination or it is at the origin. So there we have to make the corrections. We have to put the corrective actions over that particular point. So the values in degrees can be substituted here and you can have the asymmetry multiplier. For the case of frequency multiplier and the coupling multiplier, we have to follow two tables. This is for frequency multiplier. If the height is, which is about less than 70 centimeters, then we have to go for this table. If it is more than 30 inches, we have to go for this table. So that way we can find out the frequency multiplier. There are three things: duration, either it is less than 1 hour, less than 2 hours and more than 1 hour, or less than 8 hours or more than 2 hours. So now there are three tables for this. One is this, one is this, one is this. Within that we have either vertical distances less than 70 centimeters or more than 75 centimeters. So for this first one we have to follow, and for the other we have to follow the second one. This is for second one, this is for the first one, and the same over here and over here. With respect to a particular value of frequency, with respect to three variables, we have to see the frequency multiplier. Frequency multiplier is a function of vertical distance, duration of work, as well as frequency of work. So three parameters define the frequency multiplier. So we can pick up a particular value. Suppose frequency is 8, vertical distance is less than 70, and hours are 8 hours job. So frequency multiplier will be point. Frequency multiplier will be 0.8. So the next is coupling multiplier. For coupling multiplier, we have to see whether the coupling is good, fair or poor. poor means it is difficult to hold the job. Fair means it is okay to hold the job. Good means it is comfortable to hold the job. And with respect to the vertical distance. So here coupling multiplier is a function of vertical distance as well as quality of coupling. Okay, so this way we can pick up the multiplier value out of these values. So if coupling is poor and vertical distance is less than 75, then we have to see this particular point and the coupling multiplier will be 0.90. When we know all the multipliers, this is our worksheet for NIOSH Lifting Equation. If any example is given, we have to see what are the values of horizontal distance, vertical distance, difference of the distances, difference of the vertical distances, which will be the distance moved by the object in vertical direction, then asymmetry, then frequency of lift, then duration of work, and the type of coupling. So these are the factors. So at origin, we have to see two things: horizontal distance, vertical distance, and asymmetry. At destination, we have to see horizontal and vertical distance and asymmetry. Then rest of the factors will remain same for the job. So what is an initial thing in this worksheet is write down which department they are. If suppose warehouse 1, job is lifting catch-up boxes. Analysis name NIOSH Lifting Index. You can provide a particular date, job description, what he is doing in details. We can give over here. Now, what is an average weight person lift during the working hours? Suppose this is 30 kg and maximum is suppose 40 kg. Horizontal distance at the destination is suppose horizontal distance at the destination. So one point will be destination and the other point will be, one point will be origin and destination. The load has to be transferred from this point to this point, and the person is standing over here. So distances we have to calculate. So horizontal distance, suppose it is 30 centimeter. Vertical distance, suppose 70 centimeter. This was at the origin, and for the destination, the values are horizontal distance, let's have 50 centimeter, and vertical distance, let's have 90 centimeters. And vertical distance will be nothing but 99 as 70, so it will be 20 centimeters. Asymmetry, suppose at the origin, the person is twisted somehow, but at the destination, suppose person need not to have any asymmetry. So at destination, asymmetry may be 0 degrees. For origin, suppose he is lifting from a side table, so it will maybe suppose 30 degrees. Frequency of lifts, we can say 8. Work hour, suppose 2 hours, and the coupling is suppose fair. So if we have these things, we will go back to the table and we will see that what are the values of the multipliers. Then, so in this we will see the value as per the multiplier for 2 hours duration. So it will be somewhere around 0.35. Then coupling, if it is fair, less than this, 0.95. So these multipliers 0.35, 0.95. So 0.35, 0.95. And these things we have to calculate as per HM is 25 by H. this is some formula. Then distance also has a formula, asymmetry has a formula. Once we know all these things, so in this, if we have to calculate vertical multiplier, the value is vertical multiplier is nothing but 1 minus 0.003 multiplied by v minus 30. So v here is at origin is 70 and at destination is 90. So we can calculate the value and we can substitute here. dm, distance multiplier, is 0.82 plus 4.5 d. So we can substitute the value of d as 20 for both the cases, and we can put the same value for distance multiplier over here and here both. For asymmetry, here it is 30 degrees. So asymmetry multiplier is 1 minus 0.0032a. A is in degrees. So that value is 30 for the origin, but for destination it is 0. So AM will be 1 over here, but it will be some value over here. So these loads at origin, the recommended load is 25 kg for example, and for destinations it is 20 kgs. So we will calculate the lifting index. Lifting index is object weight and average is 30. So 30 upon 25 will be lifting index at the origin, and that will be 1.2, and here it will be 30 upon 20. So lifting index will be 1.5. Lifting index at origin is more than 1, that is equal to 1.2. Lifting index at destination is more than 1, that is equal to 1.5. Now we have to see which multiplier is contributing more in this case towards the reducing the recommended weight limits. See, if suppose frequency multiplier is contributing more, vertical distance is contributing more, there the correction is necessary. The same thing we can apply to this example which is shown here. This is an example of putting bags in a rover, and in that case we can calculate the values for lifting index at origin and lifting index at destination. This is all about NIOSH Lifting Equation and calculating the recommended weight limit, which help us in knowing the lifting index that tells us about the severity of the risk of back pain. To reduce that, we have to see which multiplier is responsible for reducing the weight limit. And if we have identified the multiplier, then we can identify the variable which had to be controlled, and we can make the corrective and necessary actions for redesigning the task. Thank you very much. You can apply in the industry as an Ergonomics. Good luck.